Alright class, this lesson's a little more tricky. It's building quadratic models from data. The hardest part about this is coming up with the equations based on the model. So for example 1, Beth has 3,000 feet of fencing to enclose a rectangular field. So up here I'm going to write a rectangular field. I'm going to call x the width because that's what it says in the problem, and I'll make y the length. Alright, so we know we have 3,000 feet. When you build a fence, you have to think, what is that? Is that like area, perimeter? And hopefully you guys realize that 3,000 feet would be the perimeter. So we can say that for the perimeter equation, that 3,000 is equal to, and then if you do the perimeter here, you have 2x plus 2y. So that's an equation we're going to use later. Now we have to look and see what we're actually trying to do. I was just using the information given. It says we need to find an equation for the area of this rectangle with respect to the letter x. Well, the problem is, right now, the area of this rectangle is x times y. So I can't use that because there are two letters. So we need to get rid of this letter here somehow. Which means, if you underline the letter you want to get rid of, you want to underline it in the other equation, and that's the letter you want to solve for. So if I want to solve for this, the first thing I would do is subtract the 2x, and then I would divide by 2. And you get y is equal to 1,500 minus x. The whole reason we do this is that now you can sub that in over here. So now I could come up with a formula, a sub x is equal to x times 1,500 minus x. And honestly, if you just leave it like that, I'm fine. Or you can distribute it out and say it's negative x squared plus 15x. Okay? Well, actually, you know what? Let's do it without a calculator. So, negative x squared plus 1,500x. So for what value is x the area the largest? Now, you could just look at your calculator, but that might take you longer than just throwing it right into your formula you knew from before. You should note that the area will be the largest at the vertex because this is an upside down quadratic. So this will be x comma a sub x. So if you want to find the vertex, all you have to do is x equals negative b over 2a. And if you do that, you get that x is equal to 750 feet. And you didn't have to do the second trace maximum and find that. Now you take that number and say, well, what is a of 750? Well, a of 750 is negative 750 squared plus 1,500 times 750. So the maximum area you would get is 562,500 square feet. Okay? That part's not that difficult. The hardest part for these problems is coming up with this formula right here, a sub x, using the two formulas and getting what you need to do. Alright, now we're going to look at the next one. For this one we're going to use a calculator just because the numbers are a little bit more, and it tells you to use a graphing utility, which is a calculator. So when you see use a graphing utility, that means use your graphing calculator. I guess you can use Desmos on your computer if you want. And this is telling you already your domain. Okay, this is telling you your domain. So anyway, what's happening here is we have a projectile that's fired at an inclination or an angle of 45 degrees with a muzzle velocity of 100 feet per second. What's nice about this problem is I already give you the equation. So you do not need to do what you did in part A and come up with the missing equation. This is literally just plugging into your calculator. So what you want to do is go to your calculator and go to your y1. So I'll do this on my screen right here. And then you're going to type in the equation. So you can do alpha y equal and hit enter to get your fraction. Negative 32 x squared divided by 100 squared, I believe it is. Yeah. And then plus x. Okay, so now we have to go to our window first of all. We know our window needs to be, oh, it's already set up for this, so I must have done this recently. You make your xmin the minimum of the domain, your xmax 350, and then I just chose random value. From ymin I made it a little bit below 0 so I could find the 0 if I need to. And then the xmax, I just picked 600 to guess. And then I hit graph. Alright, 600 might have been a little too high, but at least I still see it. So it says at what horizontal distance is the height of the projectile maximum. So for this one we're going to do second trace maximum. And then, you have to do the whole left bound, right bound thing, hopefully. And I might not show you guys this part on the third problem. I might just tell you what the numbers are because I don't want to go through the whole process of getting... It's a little slower on this thing. Okay, so there's the left bound. It went a little too far, but that's okay. You just have to get the right bound then. I have to go a little bit further. Enter, and then the middle. So what you get is, I guess, okay, there it goes. 156.25 and 78.125. So this looks like this, and the vertex is at 156.25 and then 78.125. So it says what horizontal distance. That's usually x. So we would say the horizontal distance is 156.25 when it's at its highest point. And then it says find the maximum height. You guys already did that. It's the other number in the vertex. It's the y value. So the maximum height is just 78.125 feet. Okay? Then it says at what horizontal distance will it strike the ground? This is when you want y equals 0. So you plug that into your y2. Alright? And then you can just do second, and I already did that, second trace 5 for intersect. Or you can use the 0 function. I like just intersect, and then I hit enter 3 times. You don't even really have to go close to it because it'll jump over there at the intersection. Sure enough, it goes 312.5. Which makes sense in this problem because it starts at 0 and then ends at 0. So it should be double the 156.25 because the 156.25 is directly in the middle. So the end is then 312.5. So we would say it's 312.5 feet. For that one. So if I give you a model, you can just use your calculator. But the first one was actually easier to do by hand. So, alright, this one's a little trickier, but it's kind of like what we were doing earlier when we were coming up with vertex form and finding the A value. We have to do the same thing, get an equation that models this. So we have a suspension bridge that is along its length has twin buildings that are 400 feet apart. So here's one building, here's the other building. So these cables are going to the top of the buildings. I'll draw the building here and here. They extend 75 above the road. The cable touches right in the middle of the bridge. This whole thing, it says, spans 400. So to do a problem like this, you have to come up with 2 coordinates. The first one, you can make your vertex be whatever it is. So I'm going to decide that this is my coordinate plane. So I'm going to say that the vertex is at 0, 0. I'm going to say that this point is 0, 0. So if that's the case, and the whole thing is 400, this little sliver from here to here is going to be 200. So to get to this point up here, because we need points on the parabola, you would say it's x of 200 and then a y of 75. So the second point is 200, 75 from this 0, 0 point. Okay? So find an equation to model this parabola. Well, you first just put it in vertex form. Vertex form is A, x minus the x coordinate squared plus the y coordinate. Since x and y are both 0, we don't have to worry about those with our problem. All we have to do now is find our A value. And just like before, when we were doing this on the previous worksheet, you just take the other point on your parabola, in this case our 270, 75, and we stick that in. So now my y value is 75. I have a times x squared, which is 200 squared. Once you get your numbers in, all you have to do is solve. So this would be 40,000 a. And when you divide, you get an a of 3 over 1600. So you just plug that back in, and your final equation to model the suspension bridge would be y equals 3 over 1600 x squared. And again, that's based on making the vertex the center at 0, 0. Alright, and then once you have the equation, again, that's probably the hardest part of these problems. It's now just becomes a matter of plugging in your numbers. We want to know how high the cables are 100 meters from the center. So if my center is at 0, 0, that would be an x value of just 100, because you're 100 away from 0. You could actually put 100 or negative 100 in, it would not matter. You should get the same answer either way, because the square would cancel out your negative. So when I plug in 100 squared times 3 over 1600, you do some quick calculations, and you get 18.75. So the height of the cables are 18.75 meters when you are halfway between the center of the suspension cables and the tower. Okay, and that's it with modeling. Again, just double check and practice coming up with the models on number 1 and number 3. That is the most challenging part of these. Everything else you guys were just building on. So I'll see you guys on the next one.